All right, now we're going to be talking about binary outcomes. So a binary outcome is another way of talking about a categorical outcome that just has two categories. So the most common model that's used in this case is logistic regression. So remember how we were talking about how there are these different functions of the outcome that we can use in order to create these models. And so for logistic regression, the function of the outcome is going to be the logit. So the logit is defined as the log of the probability of having the outcome divided by the probability of not having the outcome. So here our estimate is going to be an odds ratio, which is a transformation of the coefficient. So it's an exponentiation of the coefficient from that model that we just discussed. And logistic regression, so it's used when the outcome is binary, but like linear regression, the exposure can be any variable type. So if the exposure is continuous, then the interpretation of an odds ratio is going to be the odds of the outcome for a 1 unit increase in the exposure, holding all other variables constant. And in the categorical case, then the odds ratio is the odds that the outcome will occur with the exposure divided by the odds that the outcome will occur without the exposure, holding all variables constant. And so as we discussed in the previous section, it's really crucial to examine which, if any, variables are adjusted for, especially if the study wasn't randomized. Okay, so the null hypothesis here for an odds ratio is that that odds ratio is equal to 0. And so the no effect is going to be if odds ratio is equal to 0. So this generally means that in a confidence interval if it includes 1, then it's not statistically significant. So if the confidence interval of that odds ratio includes 1, it's not statistically significant. And likewise, if the confidence interval for the odds ratio does not include 1, so if it's, if the lower bound is greater than 1 or the upper bound is less than 1, then it is statistically significant. So odds ratios greater than 1 indicate that an exposure is associated with the higher odds of an outcome, and an odds ratio less than 1 indicates that the exposure is associated with lower odds of an outcome. So I think it can be a little bit easier to understand what an odds ratio really is if we look at a univariable example. And so here's a 2x2 table, and we just have an exposure and outcome. So we're just looking at this univariable relationship between an exposure and outcome. And so the A cell here indicates a patient who was exposed and experienced the outcome. The B cell is a patient who was exposed and did not experience the outcome. The C cell is the unexposed patient that experienced the outcome, and the D cell is the unexposed patient that did not experience the outcome. So the odds ratio then is going to be the odds of the outcome in the exposure group, so A over B, divided by the odds of the outcome in the unexposed group, C over D. And this is mathematically equivalent to A over C over B over D, and it's also mathematically equivalent to A times D over B times C. And so you might see, if you're looking at these 2x2 tables, you might see it kind of written a couple different ways, but these all mathematically will end up giving you the same answer. But for this, we're assuming that there's just two categories of exposure, that exposed or unexposed. But it's possible to have many categories similar to what we talked about in the linear regression case. And so again, here, the researcher is just going to choose that referent category, and they're going to compare all the other exposures to that category. Okay, so another type of regression for binary outcomes is known as log linear regression. And so now that function of the outcome is going to be the log, and this lets you calculate what's known as a relative risk. And so now, again, that's going to be that exponentiation of the coefficient from this log linear regression. Sometimes people refer to this as Poisson regression, or you might hear researchers talking about doing a log binomial regression. But basically, these log linear regressions, they give this relative risk, which in the continuous case can be interpreted as the risk of an outcome for a 1 unit increase in the exposure. And in the categorical case, a relative risk is going to be the probability that the outcome will occur with the exposure divided by the probability that the outcome will occur without the exposure, holding all other variables constant. And so it's important here to recognize the difference between a relative risk and an odds ratio, because sometimes those are mixed up. But a relative risk here is talking about the probability of the outcome, whereas the odds ratio, we were talking about the odds of an outcome. So those two things are different. And similar to that odds ratio, we also can just pick a referent group if there are multiple exposure categories. And so then it would be the probability that the outcome occurs with exposure group A, or whatever exposure group you want to compare to, divided by the probability that the outcome will occur in that referent group that you choose, holding all other variables constant. Okay, so I'm going to come back to that 2x2 example so I can really highlight how this relative risk is different from an odds ratio. So remember before, that odds ratio is calculated by the odds of having the outcome in the exposure group divided by the odds of having the outcome in the unexposed group. So A over B over C over D. And now the relative risk is calculated as A, that the number of exposed with the outcome, over A plus B, so the total number of exposed. So now that's that probability of the total number of exposed. So that's that probability of having the outcome in the exposure group. And then that's going to be divided by C over C plus D. And so the unexposed with the outcome divided by C plus D, the total number of unexposed. So now that's the probability of having the outcome among the unexposed. So the probability is going to be different than the odds. And that's important to remember just kind of for language purposes. And so here, that relative risk in terms of hypothesis testing, the null hypothesis is going to be 1 again. And so relative risk, when you have a confidence interval that includes 1, then it's going to be non-significant. And similarly, if you have a confidence interval that does not include 1, then it is going to be statistically significant. So an odds ratio, as we've highlighted, is different from a risk ratio, but an odds ratio actually will approximate a risk ratio when the outcome is rare. And so this is also important to think about because sometimes that language can be interchangeable in this case where the outcome is rare. Okay, so let's look at an example. So here's a study that looks at the relationship between myocardial infarction and alcohol consumption. So here it states, the habit of binge drinking during the previous 12 months was significantly more common in cases than controls, adjusted odds ratio of 2.2. And so this can be interpreted as the odds of myocardial infarction is 2.2 times higher in those who binge drink compared to those who do not, with a 95% confidence interval of 1.2 to 4.2. And you can find this article in PLOS One.